So let's do a practice problem for Anova. So groups of men from 4 different areas of the country are to be tested for their mean weights. The entries in the tables are the weights for the different groups. At a 0.5 level of significance, are the mean weights similar throughout the country? So here's group 1, group 2, group 3, group 4. So the first question is, how many groups of men are we looking at? And the answer is 4, because there's 4 groups. Is this qualitative or quantitative data? This is quantitative data, and the reason it's quantitative data is because it's in groups of mean weight. So while the groups themselves are categorical, the weights within the groups are the quant. So we're going to consider this quantitative data. And what test are we going to run? We're going to run an Anova because we want to see if there's any differences or similarities in the weights throughout the country. So what is my null hypothesis? So my HO is going to be that, I'm going to use the symbols too to make it easier. The mean, oops, not that one. The mean of group 1 equals the mean of group 2 equals the mean of group 3 equals the mean of group 4. Okay, so that's that easy. So what is my alternative? HA, at least one group mean is different. I could have them all being different from each other, or I could have them maybe 3 are similar and 1 is different, maybe 2 is different and 2 are similar. For us to support that alternative, at least 1 has to be different. Okay, so what is the F statistic? So now I'm going to go ahead and use the social science site. I'm going to go to calculator, and then I'm going to go look right here, and it says one-way Anova calculator for independent means. So what I'm going to do is I'm going to bring my stuff up too so I can remember it, and it'll be easier for me to do. So for here, it's 216, 198, or look what I'm going to do. Sometimes it will let you do this. I'm going to copy and paste, and let's see if it does. Yep, and I'm going to get rid of those first 2 that I had. So sometimes if you can put it in a Word document, it will let you paste it. And then I'm going to go get to group 2. If not, make sure to write them down correctly, or make sure that you enter them correctly so that you get it right. Because if not, if you make one typo, it's going to be wrong. And let me go here and do this. Okay. Okay, so I have all my data in. My significance level is 0.05, and then I hit calculate. So look, I got all the information that I needed. All right, so the first thing I did, I have my treatments. And this is kind of cool. And if I ask for this on a test, you're going to know where it is. Oops, let me hide that. Sorry about that. So from here, I have group 1's mean and standard deviation, group 2's mean and standard deviation, group 3's mean and standard deviation, group 4 mean and standard deviation. So look here. For group 1, the average weight was 203.4 pounds, and the standard deviation is 25.23. For group 2, the mean weight was 227.4 pounds, and the standard deviation was 33. For here, the mean weight was 183, and the standard deviation was 15. From here, the mean was, for group 4, was 192.8, and the standard deviation was 23. This over here is the group's means total, 201.65, and the total standard deviation for all 4 groups. So each of these is individual, and these are all together. So down here, this is the Anova table. So basically what this table tells me is I'm looking at the sum of squares between each mean, and there's the degrees of freedom, and that's the mean squared. And this is within treatments, and that's within each sample of itself. So the most important thing that I'm going to need is this F value of 2.897, or I could round up to 2.9, and the P value of 0.067. So what I'm going to do here is I'm going to go back to here, and it says my F value, we're going to put the F value as 2.90, and the P value was 0.067. And it might ask for a different decimal place in the homework, just make sure to look. Okay, so I'm going to do this. So I'm going to compare my P to my level of significance. So let's do this. 0.067 is greater than 0.05. So that is a true statement. Because of that, I fail to reject the null. Does that make sense what I did? Because remember the rules of rejection, we've been through them several times. So 0.067 is greater than 0.05, I fail to reject the null. So what is my proper conclusion? And remember up here, I wanted to know if the mean weights are the same. So at the 0.05 level of significance, the mean weights are similar. And remember, I'm going back and I'm going to make sure that I have it for my conclusion is pretty much the same as what I ask in the question. And the reason is this. It wouldn't make sense for me to say at the 0.5 level of significance, we did not find that at least one group was different. It's easier for us to say at the 0.05 level of significance, the mean weights are similar throughout the country. And again, that's what I asked in the original problem, and I want to conclude that way. It's kind of like closing the loop.